All right, so welcome everyone to this month's Bi-State Climate Webinar. I'm Dwayne Friend. I'm with the University of Illinois Extension. And today we have Chris Evans. And Chris is an extension forestry and research specialist at the University of Illinois, where he conducts trainings for natural resource professionals and landowners, develops educational programs, and conducts applied research. His areas of interest include forest health, invasive species, hardwoods ecosystem management, and agroforestry. And today we've asked him to talk a little bit about forestry and climate change. Chris, welcome, and the floor is yours.
All righty. Thank you so much, Dwayne. I'm happy to have everybody here. I'm actually going to turn my video off, I think, and that way you all can see my whole slides. So let me figure out how to do that real quick. There we go. So hopefully you can see my whole slides. I appreciate the opportunity to talk about this. It's such an important topic, climate change and forestry. I'll start just by saying that I am by no means a climate change expert. I mean, by any means, but I do a lot of work in forestry, and I think about climate change a lot, and then I've looked at it a lot. So I'm going to talk in a lot of generalities today instead of specifics, but hopefully we'll all get something out of it. And I'm pretty low key. I'll try to finish up with plenty of time for questions, and so I'll love to discuss afterwards. So what I wanted to do was start with just a general overview of the central hardwood forest, and that's the forest broadly what we see in Illinois and Indiana, and then the kind of current threats and challenges we have with these central hardwood forest we have in these two states, and then get into climate change, kind of how we expect climate change to impact forest as well as impact those threats and challenges that we're already facing. Some management steps to kind of reduce those impacts or ameliorate them some. And then a little bit at the end of the role of forest and especially reforestation in mitigating climate change. And so let's just jump right into it then. And so Illinois and Indiana are kind of the heart of what's called the central hardwood forest ecosystem. And it's called that because as you go south or north, or even west, from this area identified in the map here, you get into areas that either are not forested much, so going west, or north and south, you get into areas that are dominated by conifers, right? Where they're mostly pines, but it could be spruce and stuff to the north as well. And so this block we see here, while it does have some conifers in it, it is predominantly deciduous hardwoods. And so that's kind of where this ecosystem is lumped together. And as you can see, Illinois and Indiana, pretty much all of our forest and our ecosystems kind of fall into this group. And so this area is kind of characterized by really high tree diversity. So there's a lot of different hardwood species in here, in addition to some conifers. And really most of our systems here are dominated by oaks and hickories, not only by number of species. You can see there's over 20 oaks and over 10 hickories, but also dominated just in terms of the number of trees out on the landscape. Many of these ecosystems, the dominant trees are oaks and hickories. But I will say this whole system here, it's very big and broad, and even within Illinois and Indiana, our forests are not monotypical. They're very, very diverse in terms of different specific types of forests, and that's really due to a lot to the geology and the glacial history of the sites. So there's a lot of diversity in these two states, and so even though we all fall within this central hardwoods ecosystem, a lot of differences, local differences. And so just one example here, and since I'm from Illinois, a lot of my examples are from Illinois. But the same thing applies certainly to Indiana ecosystems, in that in Illinois, the vast majority of our forests in Illinois are considered and have been classified as oak hickory forest. And so 68% of the total forest in Illinois, or a little over 3 million acres, is oak hickory. And so not only is it oak hickory forest type, but oak really has been the dominant component of this forest and many forests over the last about 8,000 years in this region, and it's really still the dominant canopy species, oaks are. And you can see that just looking at, I don't know why my slides are self-advancing, sorry there. You can just see that by looking at the number of species. And so this is the number of live volume in trees in Illinois. And this is an estimated live volume based upon kind of repeated metrics. And you can see out of the top 10 most volumetric trees in Illinois, 3 of them are oaks and 1 are a hickory. And so we still have a lot of oaks and hickories. They're still the dominant trees in the state. And there's a lot of different ecosystem types here. Again, that falls within this. And I'm going to quickly stop share, sorry, because my slides are self-advancing, and then I'm going to stop that because it's bugging me. Sorry about that. I don't know why they're self-advancing. But I'll fix it quickly here a second.
And while Chris is working on that, in case you haven't seen the in the chat, anybody is welcome to put questions into the chat box. We'll get to those after Chris has done his talk.
Thanks, Dwayne. Now my PowerPoint says not responding. I am sorry. It's taking a second here for some weird reason. It's always you get technical errors whenever you're presenting.
Well, like I always say, when the extension, the technology doesn't work, we're always ready to back it up with an interpretive dance.
You maybe. I don't think anybody wants to see me dance. All right. So you should be able to see my screen now.
Yes.
Awesome. Thank you so much. Sorry, guys, for this brief interruption. As I was saying, just kind of going over some of the different types of forested ecosystems that you can find in the central hardwoods. There's bottomland, hardwood riparian systems. And so in this case, you'll find big trees, very, very rich soils, a lot of alluvium. And so you'll have one example might be, the fantastic overcup oak that you see here, right? So that's a classic species kind of in these riparian areas. Or we could have rich woods, cove sites. These are colluvial soils with soils kind of eroding down from the uplands and then depositing tons of nutrients into these systems. And this is really the heart of where you see our wildflowers in this region. And so you may see things like cherry bark oak in here, northern red oak or sugar maple kind of fit into these ecosystems. Now, mesic uplands. So mesic upland is kind of, I usually describe it as the standard forest that everybody thinks of when they think of a forest in this region. So this is kind of the white oak, black oak, shagbark hickory forest. And this is by far the most abundant forest type across both of these states, right? It's not really, really dry, not really, really wet. That's kind of where that word mesic, it's kind of in the middle in there. But again, the majority of our forest falls into this category. And this is where you're going to find white oaks at, right? Primarily, they really love these conditions right there. Again, very, very abundant forest type. Then as you get farther up, you get into dry uplands. And we do have a lot of these in certain areas of both of these states. And these are drier soils, smaller trees, usually more wide spacing, a lot of times more light to them. And on the kind of far extreme, you may find things like blackjack oak there. So very, very dry sites. And then even our forests you can classify some of these more open habitats like woodlands, barrens, glades that kind of fall into a forested category, even though they have a lot of open land, sun-loving plants. And so post oaks would be a great example of a species that you may find in, these sandstone barrens or chinkapin oaks in some of our limestone barrens. And then finally, oak savannas, right? So these are the edge of the prairies, fire kind of maintained ecosystems. And of course, the classic bur oak is what you'd expect to see, in these savannas. And so that's just briefly showing you like the wide diversity of forest and forest types and trees that you would find in Illinois and Indiana. But just a little bit about these central hardwoods ecology. The forest here can really be characterized by change over time. I think people risk the assumption that a forest are a static system. They've always been kind of forest with big trees and they look like that, right? But really forests are very, very dynamic systems that are continually changing over time. And it really depends on the resource availability, the local site conditions, the interaction between species that kind of determines what there. But largely, our forest in the central hardwoods can be called a disturbance-driven ecosystem. There's a lot of natural disturbance that has been happening over the last 8,000 years, whether that's flooding, as you see in the top left, drought, the bottom left, natural native tree diseases like the root rots and things you see in the central, heavy windstorms and other kind of weather events, as well as fire, right? All of these are disturbances that that occur on the landscape naturally and have occurred on the landscape naturally for thousands of years. And that's kind of what I'm talking about with this disturbance maintained ecosystem. It's not a system that drives itself to some final state and it stays there. It's constantly in flux and constantly getting reset through a lot of disturbances. And it's really evolved that way to kind of utilize these disturbances or even need these disturbances to kind of maintain the high level of diversity we see in our forest. So that's kind of what the forest are. Naturally, there are some threats to forest, and then we're going to tie these into climate change here in a little bit. But it's kind of the four big threats you would consider it to our forest here in the central hardwoods. Mesification, and I'll talk about that in a second, invasive species, poor management or even lack of management, and then fragmentation and just loss of forest to other land uses. And so mesification, this is really the process of losing those disturbances in our ecosystems. As I mentioned, especially our oaks and hickories are kind of a mid-successional group of species. They thrive on kind of frequent disturbance to kind of maintain them. And there's whole suites of other plants and animals that have evolved kind of in the same kind of high disturbance environment that really gives us our diversity. So mesification really is what happens when you lose those disturbances. So you may lose fire or something out of an ecosystem, and then you slowly replace these mid-successional species with species that thrive better on a lack of disturbance and better in higher shade environments. And so these we call them mesic species, or species that like it a little more moist. And so it drives itself really to change the system over time because we're losing that disturbance. So this is just a quick little slide here. And if you're a master naturalist, you may recognize this from the forestry chapter, but this is basically shade tolerant species. And on the right are intolerant species that really can't handle any shade. And on the left are tolerant species that can grow up even in heavy shade. And so as you can see, oaks and hickories fall into that intermediate state where they need some level of disturbance. And lack of disturbance in our systems, this mesification process, drives the forest to the left in this graph. It drives it towards the species that can handle more shade and less disturbance. And so if you see there, beech, basswood, sugar maple, hornbeam, and some of these kind of fall into that category. And so that's kind of what we're seeing in a lot of our system is this movement towards these shade tolerant species. And this is a classic example, right? So here's a big, beautiful oak right in the middle of the screen, and then everything little around it would be sugar maples. Same thing here, only with beech, right? So pretty common, unfortunately, throughout Illinois and Indiana is this kind of movement towards these shade tolerant species, this mesification, as I called it. And so this allows shade tolerant species to colonize. It allows kind of, and that leads to a reduction in our oak seedling development. You get this dense mid-story layer of maples or beeches or other species that really monopolizes the lights. And that really changes the conditions of the forest, the light conditions of the forest, the openness of the forest, the humidity of the forest, and it can restrict access for birds and bats and insects that require or prefer these open forest environments. it can change the light, and you lose understory plants that may be nectar resources and forage for wildlife. And so we do see big diversity changes when a system gets pushed too far in that direction. And we're seeing this on the landscape now. This is not just a theoretical thing. If you look at this data, and this is data from 2015, and this is in oak hickory forest. So this is forests that already have an overstory dominated by oak and hickory. You can see in terms of tree seedlings that oaks and hickories are way down on the list. And there's many, many other species that are just reproducing at much higher rates in oak hickory forest than oaks and hickories, right? So it's kind of evidence of mesification in the next generation of trees coming on. And just one last, I don't want to beat it to death here, but this is one last slide. And I love this picture because this is a beautiful, beautiful white oak. It towers above everything else. It's 130, almost 130 feet tall. And you can see it's really a neat, healthy tree, but everywhere around it, and you can see in all the leaves that you see in the trees underneath of this white oak, every one of those leaves are a sugar maple leaf, right? So just another classic example of mesification. And in talking about kind of the diversity of our systems, and we're not talking just about trees, but overall forested ecosystems and all the understory diversity. These are pictures from Trail State Forest, which is in southwestern Illinois, but the same story can be told anywhere across these two states. You can see here on the edge of this forest, right on the edge next to the road, where there are some higher light availabilities because of the road. We have suites of really neat native plants. There's Culver's root in there. There's sunflowers in there. You can see blooming, and they're all kind of concentrated right on the edge of the forest where there's enough light. But as you go back into the forest and look back in there, you lose all these species, right? There's some vines in there, a lot of poison ivy, and a few things, but by and large, the wildflowers, if you will, the native plants that could thrive and dominate these forested understories and provide so much habitat and food, are just holding on at the edges. And as you go back into the forest, it's a dark, bare place, right? So that's mesification. A couple other threats before I get into climate change proper. Invasive species are obviously a huge threat to our ecosystems. Here is just a look at emerald ash borer on the top right, and then a stand of ash that has been completely killed by emerald ash borer kind of front and center. It's not only insects, there's plants and diseases and other things. And you all may have heard the news that spotted lanternfly, which is the latest invasive insect that's just been found in Illinois. It was just released yesterday, I think was the news about it, but it was found about a week ago. And so that's just another one of these invasive insects issues. But we also have a lot of invasive plants in our forest, right? Roundleaf bittersweet, Japanese honeysuckle, autumn olive are just three here, but we deal with many, many invasive plants in Illinois and Indiana. And so a couple more just real quick kind of threats that I believe are major threats to our forest. One is poor management choices, right? And so we have a history of abuse and neglect, I guess you would call it, in our forest throughout the central hardwoods throughout both of these states, where the forests were either forgotten about and not managed, and nothing happened and allowed to kind of move into these mesic states, or they were cut really heavy or cut in a way as to not provide for kind of sustainability. And so this is just an example. Here's a beautiful white oak forest, even though there's a lot of maple in there. And this shot right here was within this same ecosystem, and it was harvested in a poor way probably 25 years ago. And now there's no oaks left, and it's just a scramble of sugar maple and black cherry, right? And so this would have been a pretty diverse oak hickory system, but through past poor management decisions, now it's kind of much lower in diversity and in quality, kind of because of landowners' choices in the past. And then finally, just one other challenge to our forest would be fragmentation and forest loss. Our forests are often getting removed and deforestation due to other land use changes, whether that's urbanization or sprawl or agriculture or a lot of other reasons. We've lost much of our forest throughout both of these states. Even though we're getting some back and growing some back, and that's wonderful, this still continues to be a threat to our forest. And fragmentation, particularly, as you know, kind of blocks gene flow, and we get kind of island habitats, which are more susceptible to kind of local extirpations and genetic problems with a lot of the organisms. Alrighty, so that's just kind of a state where we're at in forestry right now. And I really wanted to cover that at the beginning because I think it's important to know where we're at, because then we can talk about how climate change is currently and may in the future both alter and change our forested ecosystems and impact those threats. And so what I've done for this section really is lean really heavily on these two documents. And so there's an assessment of the impacts of climate change in Illinois that was produced by the Nature Conservancy. This is a fairly recent, a couple years ago document, and then an older document called the Central Hardwoods Ecosystem Vulnerability Assessment. And this really focuses on climate change. Now, there is an assessment of climate change for Indiana as well, and I'm sure it's very similar to the one for Illinois, and it has a lot of good information in it. Just since I'm from Illinois, I tended to lean heavily on the Illinois one, but if you're from Indiana listening to this, certainly get that document, look it up, and there's some great resources in there, I'm sure. So I'm actually going to pull direct quotes from both of these documents in this section. So you'll see quotes around them. You know, that's not me. It's actually pulled directly from these reports. And so what can we expect with climate change just in general? And I know you all know this, but it kind of fits probably every one of your talks if I mentioned this, but I think it's worth just kind of repeating that, you know, these shifts in climates that are expected. And so this region, we're expecting warmer and wetter springs, hotter and drier summers moving through, and these kind of increases in temperature extremes. And so some examples in these reports would be more days per year that are warmer than 95 degrees and a greater frequency of multi-day heat waves moving in. This whole entire central hardwoods region is projected to see the greatest increase in events, could experience 20 to 30 more extremely hot days even by mid-century, and 25 to 38 fewer days below freezing by the end of the 21st century. And so warmer and wetter for sure. We can also expect more extreme weather events moving forward, and particularly drought, right? So there's some quotes here. Surface soil moisture projected to decrease in this area over the next century. Total soil moisture projected to decrease, particularly in late summer and fall, as well as some increases in winter and spring, right? So drier in the summer and fall, wetter in the winter and spring. Changes in the duration of drought periods in Illinois and Indiana. In both time period, duration of drought, and also the kind of the scope, the range of the drought. So it'd be more of a regional phenomenon, droughts will, instead of a small localized problem. So it's be longer, larger areas that have more severe drought, and at the same time, potentially a higher magnitude of flooding, especially in the spring and winter, because total runoff increases and peak stream flows due to heavier rain events, and then even potentially more flashy summer and fall floods as we get more of our rainfall kind of happening in fewer events. So that's kind of what we can expect, or some of the changes due to climate change in terms of kind of how it's actually going to look. Now, how does that impact our forest? And I'll start by saying, you know, it's really complex and it varies by region and by species. Simply because our forests are so abundant, there's certain species that do well that will actually kind of, the climate will move closer to their preferred habitat, and there's certain species that'll move farther away from their preferred climate, you know, conditions. But overall, looking at our systems in general, they're predicted to remain abundant, right? So we're not going to completely lose our forest. We're going to maintain the same amount of forest we have now, roughly, again, and lots of forest on the landscape in both of these states, and they're going to remain to be fairly diverse, right? And so I think that's a great thing that it's predicted, is that we're not going to see the end of forest due to climate change. They're going to stay on the landscape, but we will see big changes to our forest as they are now. And so there's lots of changes in the suitability of different tree species, and there's changes to these current threats to our forest. So we can expect, increases in invasive species problems, problems with oak decline and changes in fire, especially with fire adapted systems. And it was predicted in these reports that these mesic upland forests that I talked about, the white oak and shagbark hickory forest, the most abundant forest type in both of these states, really is kind of the most vulnerable forested ecosystem to climate change. And we'll talk about why in a second. And so one thing I wanted to mention was this tree species suitability. And so this is a look, and this was the Illinois assessment. And I know there's a tree species suitability for Indiana as well. But it looked at how are these predicted changes that's going to happen with climate change, how do they impact the different species in the state, right? So warmer, wetter springs by hotter, drier summers, it may increase habitat suitability for some trees and decrease for others. So again, we still maintain some level of diversity, basically because of the variation and all the diversity of soils and geology we have. We're definitely going to see some winners and losers. And so if you get into that document, they have tables like this that have what part of the state you're talking about and the different species and how they're going to fare, right? So VP, or the dark pink one's very poor. That means that it's going to get worse for that species. And VG, or the dark green, is very good. It's going to get better for that species. And what you can see is a lot of variation in here, right? Depending on both the region of the state or the region of the whole central hardwoods or the species. And so kind of looking at it and pulling that data out and just kind of summarizing some of it, I summarize it into winners and losers. And so this is from the document here, the kind of winners. So this would be species that would be expected to cope or persist well in the changing climate across this region. And so these are species like sweet gum, winged elm, post oak for sure, followed closely by cherry bark oak, hackberry, eastern red cedar, bitternut hickory, and honey locust. So these are species that should be faring better and better. The climate should favor them more and more as we go on. Basically, as the climate shifts, these are kind of winners in our ecosystems. In terms of losers, so these are species that are predicted to do worse with climate change. Pignut hickory, black willow, basswood, pin oak, chinkapin oak, eastern white pine, quaking aspen, Ohio buckeye, and pawpaw. So some of these would be because like quaking aspen and white pines, because this region is kind of at the southern edge of their range anyway, and as we drift farther warmer, we're kind of walking out of their range. And others, it's just the combination of wet and dry and temperature just doesn't favor them as well. But these are expected to do less and less good as the climate changes. But we're also expected some species to expand their range into Illinois in this document. You can say the same thing for Indiana, but these will be farther southern species that will do better and better into this region as climate changes, right? And so loblolly pine, which is already planted widely in the southern reaches of both Indiana and Illinois, expected to keep doing better. Virginia pine, willow oak, which is already native to southern Illinois, barely, and water hickory, which is also barely native to southern Illinois. Both of those are expected to kind of have better and better habitat, as well as water oak, which is a southern species, and even live oak potentially. So these are all southern species that we may become more suitable for them moving forward. Right, so we can see these species shifts over time just in suitability. But really looking at kind of an ecosystem level and looking at this mesic forest, mesic upland systems, right? These white oaks and shagbark hickories. It's kind of varied here, but overall, many of the species like white oaks are predicted to do fair to good and some into poor. So they're kind of midland with the predictions. But the problem is some of these shade-loving species like maples, particularly, are also expected to do fair to good, or even some places very good. And so the problem was that their competition and their ability to drive this mesification that we talked about earlier, and impact our oaks even more, is a little higher. Oaks really are, most of our upland oaks like drier ecosystems, a little bit less humidity. And knowing that we're getting a little more humidity moving forward, it's going to make it potentially even harder for some of these oaks to outcompete these mesic species that are moving in. And so really the statement that the report made is what happens to these mesic upland forests, these oak hickory forests, will really hinge on how we manage these moving forward. And it's going to be even more vital that we include kind of management practices to keep oaks on the landscape moving forward if we want to maintain some level of oak dominated forest kind of into the future. It's really going to be reliant on management. In terms of the species understory, knowing that we are going to get warmer and drier in the summer, especially late summer, it may favor C4 species or species that like those hotter temperatures. The challenge with that is they also tend to like higher sunlight. So we may have climate conditions that favor higher sunlight or sunlight-loving species for a forest, but without something to create the open forest structure that allows light to get in there, we may actually see a decline in these species over time. So we may see a decrease in diversity in the understory of our forest in the absence of fire. And so I think moving forward, we can expect the need for fire as a management tool to increase in our drier upland forest to kind of maintain diversity. And so we're wanting to avoid situations like this where you have really no light getting into the understory. Otherwise, there's some rare species impacts as well. So some of the rare species that occur in the northern reaches of Indiana and Illinois, things like Canada yew and yellow birch and bunchberry, are expected to do worse, right, as we warm. And so we may lose some of these rare species just from the climate is just no longer suitable for them in the northern reaches of Indiana and Illinois. So in terms of some of these threats, it's predicted that this warmer, drier in the summer and warmer and wetter in the spring habitats could be fairly favorable for certain invasive species that like a little bit of disturbance and like a little bit of bare soil or rougher conditions. And so amber honeysuckle, roundleaf bittersweet, and Japanese stiltgrass specifically are predicted to kind of do better and become more problematic as we move along with longer growing season and milder winters, and as well as warmer temperatures and this kind of drifting to farther climates that are more similar to the south may actually increase some of the invasive species that are more well known from farther south of us into our region. And so kudzu may become more of a problem. We're already seeing Chinese privet explode in the central reaches of the central hardwoods, central Illinois, and even parts of Indiana, where that has typically been thought of as a Tennessee problem. We're seeing big expanses of it already in this region. And we can only predict kind of more expanses of some of these southern invaders into our forest. As well as some changes in the pests and pathogens, whether they're invasive or native, either one. We can expect that as the climate's changing and becoming less suitable for many trees, they're going to have higher stress levels, along with warmer temperatures and less harsh winters. We can expect maybe an increase in pests and pathogens that are currently present, both native pests and pathogens as well as invasives. We've seen there's reports out there that insects and pathogens both can be exacerbated by drought and the stressful conditions there. High spring precipitation is something that's been shown to really lead to bad outbreaks of bur oak blight. Oak decline that we're seeing is kind of driven by midsummer drought conditions, as well as increases in insect pests and pathogens. And so we may see more of these pathogens and these pests attacking our trees as our trees are higher stressed, just because they're not in as perfect of a climate for them. and this stress levels kind of lower their defenses against pests and pathogens, we may see an increase in problems with trees. As well as we may see more pests and pathogens moving into the region that currently aren't that big of a deal in the central hardwoods. We may see those moving in, and so one example would be, southern pine beetle, which has been a big problem in the South all the way up into Tennessee. We found a couple of them already in southern Illinois on pines, right? They were previously not thought to be able to survive here, but they may become more and more of a problem as they move north into this region. So there's a lot of changes to forest, right, that's going on, and just some impacts to climate change, and just kind of summarizing those. We think the forests are going to remain diverse, even though we're going to see shifts in species composition. We'll have clear winners and clear losers. We're still going to have forests that have a lot of different tree species in here, though there's going to have a lot of changes that may drive diversity down in other aspects of the forest. We may see tree damaging and stressing events like higher floods and more severe droughts may increase. Pests and pathogens may increase, and then problems with invasive species will become more of a problem as the climate changes. And so that's kind of how we can expect this to impact our forest moving forward. In terms of how can we respond to that, or what can we do to help our forests be a little more resilient, if you will, to climate change. And overall, the largest recommendation out there is to promote healthy forest. Try to maintain a diverse mix of native species through active forest management, such as thinning, prescribed fire, trying to halt some of these threats like invasive species or pests and pathogens through management. Trying to maintain all of our species on the landscape, so especially oaks and hickories, kind of through some of these practices would be very, very important to allow the system to remain as diverse as possible so they can better adapt to climate change moving forward. Other recommendations would be build connections and corridors, support the formation of large blocks of forest. This helps maintain gene flow for better adaptation and facilitate species migration through our forest, which would allow for better kind of adaptation to the changing climate and better migration or movement to find your sweet spot in the future. And then also kind of looking at which species to promote and which not during forest management, understanding that there's winners and losers, understanding that there may be new species that, or at least new genetics that we want to move into the region could be important as a kind of a long-term strategy to maintain diversity in our forest. And so, we may see things like this where we're thinning a forest to try to allow more light into the understory to keep a lot of those understory plants and those tree seedlings kind of on the landscape. Seeing oak regeneration on the landscape is a great thing, I think, now, and trying to keeping oak on the landscape for the long term is very important. The addition of prescribed fire in our forested ecosystems, that will impact some of these mesophytic species like beech here, and then try to promote, again, oaks and hickories, and trying to promote a diverse assemblage of native species on the landscape. So the higher diversity, I think, and the higher health of our systems, the better. And then controlling invasive species, because we know they drive diversity down, they stress our ecosystems, they reduce quality and forage availability and a lot of other things. So if our goal is to maintain high enough diversity, we'd want to reduce stressors like invasive species and get them as low on the landscape as possible. That'll allow as much resilience as we can. And then again, looking at this idea of what's going to be best suited in the future. And so I wanted to mention here briefly, before I get into the last section, a little bit of research that we're doing here in Southern Illinois, in cooperation with the University of Kentucky, who's really leading the research, and the Northern Region Research Station of the Forest Service. And so they are looking at white oak as a kind of keystone species in a lot of ecosystems, but understanding that white oak across the landscape is having a really hard time in terms of regeneration, growing new white oak, right? We have tons of old white oak, but not a lot of young white oak, depending on where you're at. And so what we're doing with this study, and it's being replicated across the East right now, is collecting genetic material from many different sites across the range of white oak, and then growing them together in a kind of common garden experiment to find out which ones, which genetics, which sites grow best or perform best at this local scale. And so in this site here, this is planted in Southern Illinois. We have 1,100 trees planted now, and we're going to plant 500 or 600 more next year. And these are all Quercus alba, all white oaks, and they're from 45 different locations currently across the eastern U.S., and we're going to add 18 more locations next year. But they're all the way from Florida all the way up into the central and northern Illinois, and they're all planted here in southern Illinois. It's replicated. There's 20 different individuals from each site. And what we're doing is basically watching these trees for the next 15 years and taking data on growth, survivability, form, trying to find which genetics are best suited for the local conditions in this region. And so after 15 years, the idea is to identify those, and it may not be our local genetics anymore. It may be the climate's changed so much that the genetics that are present in Southern Illinois are not the ones that are going to do well and compete well and be able to become the best white oaks in the future. It may be genetics from somewhere else, maybe farther south. We're not sure yet, but we're wanting to identify that and then utilize some of those genetics and to create seed orchards so we can produce seedlings for any reforestation projects that we're using the best performing genetics in this region, even if it's not necessarily the local genetics. And this is just basically an adaptation to changing climate. And so it's really exciting study. Again, it's being replicated across the whole eastern U.S. where white oak's native to, and with a strategy of trying to figure out how can we change, how can we adapt to climate change using kind of genetics. I think it's really, really exciting. So that's just one kind of strategy that we're employing here. And so I'll finish up, and I wanted to leave plenty of time for questions, just a little bit on this role of forest and reforestation in mitigating climate change. Everything up until now was talking about kind of current forest and how they're going to be impacted and how we can keep our current forest healthy and diverse in the face of climate change. This last little section, and I lean heavily on these two articles as well as a few other things, really talks about what's the role of forest? How can we fight climate change and slow climate change potentially using forest and reforestation? And again, this policy and ecology of forest-based climate mitigation and this improved forest management as a climate solution. These two documents are what I lean heavily on in this section. And so the idea here we're talking about is basically carbon sequestration, right? We're removing carbon from the atmosphere and to try to mitigate or lower the greenhouse gases that are in the atmosphere and trying to mitigate the emissions that we're still seeing, right? And we know that forests can serve as a natural carbon sink. Carbon gets pulled out of the atmosphere through photosynthesis and can get stored in a forested system, right? So we can create that ability to remove greenhouse gases from the environment. And it can be done through creating new forests, so reforestation. It can be done through enhancing the ability of existing forest to serve as a sink, right? You're trying to increase its ability to capture carbon and sequester carbon, or we can protect sinks. So we can protect our current forest and prevent deforestation. So all three of those strategies, creating new forest, increasing existing forest ability to sequester carbon, and preventing loss of forest, are all great strategies to maintain the ability of forest to act as a sink and sequester more carbon. I will say that there's been a lot of research on this lately, and the kind of accounting behind it, or how much forest can capture carbon and what's the most optimum rate, is very much still uncertain right now. There's a lot of research out there, a lot of stuff conflicts, and it's very situationally dependent. But we do know that forests capture and hold a lot of carbon, but we're trying to figure out exactly how that works is still a very much an active research topic right now. So just a little graph here showing forest in terms of carbon, right? And so the green box would be forest. The yellow box to the right is non-forest, right? And we can see carbon coming into a forest from the atmosphere through photosynthesis. And then all those little squares are where it's stored: above ground biomass, below ground biomass, into wood products that leave the forest, dead wood, litter, and soil, right? And there's a lot of flows in between those. There's some losses of carbon, and as well as there's reforestation, which moves non-forest into forest, right? So there's a lot of movement here, but this just kind of conceptualizes kind of the carbon flow, if you will, in and out of a forest. And so reforestation, right? Putting more forest on the landscape is one way of adding a sink or adding a system that stores carbon, especially when you're removing it, removing this either whether it's lawn situations or agricultural situations. This really does create a much more of a sink environment, right? And we're doing a lot of reforestation right now, which I think is great. There's a lot of incentives and cost share available for owners or producers or landowners to reforest sites for a lot of reasons, but including carbon sequestration. In terms of eliminating harvest or protecting from deforestation, there's a little bit of a problem there, and they call it transference or leakage, which means if you just say, I'm going to protect this forest and we're never going to harvest a tree out of this forest and it's going to become a sink and a storage for carbon, the problem comes with that is that you're not changing anything about the demand for wood. And so you may get transference where if you're not cutting from this particular block of woods, that wood's going to get cut somewhere else, right? And so you may actually, if all you do is protect certain forest, you may not actually see much of a net gain in carbon storage. You just may see carbon storage happening in different places and carbon loss happening in different places. And so that's kind of one of the problems of only looking at protection from harvest or anything as your only strategy for mitigating climate change in forest. And so there's this new thing coming out, and it's really catching on now. It's this idea of improved forest management. And so this is changing our schemes of forest management, changing the forest industry, and particularly looking at the timber harvest industry to make it more suitable or more efficient or better at capturing and holding carbon than the current forest industry is, right? And so it would be things like extending the rotations between harvest. So you're facilitating larger trees, managing stand density to make sure that you're capturing carbon capture efficiency is at peak. Creating multiple layers in a system so you're capturing as much of that sunlight as possible and you're capturing as much carbon. And then especially protecting soil-based carbon storage. And I'll talk about that just here in a second, but we do know now that soil, even in a forest, that's the vast majority of the carbon in a forest is held in the soil. And so this idea of extended rotations is a little more appropriate for plantation style forestry, a little less appropriate for our mixed hardwoods, how we do them here. But again, it wouldn't be eliminating harvest because we're not transferring that demand to somewhere else. It's delaying the harvest. It's creating longer rotation times between harvest. So you're growing a little bit bigger of trees in there. You can accumulate more carbon and woody biomass as your trees grow larger. And you still harvest out of those, but overall you're holding more biomass in these systems for a longer period of time. But it does come with some risk, right? So the longer you hold the trees there past what we consider peak economic value, there's a risk to the landowner that you're going to lose value and lose carbon due to weather events, pest and pathogen outbreaks, and things like that. So you're not capturing that carbon in a long-term storage, or you're not capturing the value of those trees. So this idea of extended rotations does have some risk involved because of that. But this idea of managing stand density, and if you know much about forest management, you know there's a term called overstocked, which just means that a forest is at a point where it's not, it's grown so much that it's basically utilizing as much energy that land can give to it, and it's not really growing that much more. It's kind of just maintaining itself, and that's what's called an overstocked forest. There's not a lot of room for new growth or putting on new wood. And so this is not a new term at all, but removing some of those trees and bringing it down into that closer into understocked or down lower into this graph of where you're at. And so you're farther away from being overstocked. allows that forest more room to grow and capture more carbon and grow more. And so the idea there is you're finding that optimum zone where that tree, that forest is capturing as much carbon, and you can do that through thinning and through tree removals and through creating a multi-layered forest where you're capturing light on different levels and retaining more trees in the forest through the harvest period instead of just straight clear cuts. Right? There's a bunch of things you can do by changing the stand density to promote the vigor and growth of residual trees, promote carbon capture to keep those acres as efficient at capturing carbon as possible, right? And so with this idea, since you're cutting some trees and you're manipulating stand density, you actually may see some short-term carbon storage decreases, but then overall the idea is the yield and long-term carbon sequestration and long-term storage benefits are increased kind of through implementing this, even though you may see some small short-term decreases, right? You're taking a longer view of it. And then the last one is just this idea of forest soils, right? Again, most of the carbon in a system, up to 55 to 60% in a forest, is actually captured in the soils, right? And so we know that any practice then that can reduce soil disturbance and reduce soil carbon loss is very, very important to increasing the carbon storage potential of a forest. And so looking at your intensity of your harvest, your skidding options, so you're not pulling full trees out, but you're leaving the treetops in the forest, restrictions on wet weather logging, using low impact equipment, all of these things can really help protect your forest soils and maintain carbon in the soils, which is where most of the carbon's stored. So that's some of the kind of simple changes you can do to forestry to really have an eye at helping with carbon storage and impacts to climate change. All righty. Again, I told you I was just scratching the surface. So quick summary. Forests are important, diverse ecosystems, that are predicted to remain diverse in this region, which is great, even with climate change. Although we do know that the threats that we're seeing can be exacerbated by climate change and may get more severe. And we know there's definite winners and losers in terms of we may see big changes in the species that can grow in our forest moving forward. And management is one tool that we can use to maintain diversity, lessen these threats, and help create some resilience in our forest to climate change. And forests can have a role to play in carbon sequestration, though we're still figuring out the level and the scope of that. But things like reforestation, protection of existing forests, and enhancement through management can be important roles that we can use to kind of optimize forest as carbon sequestration areas. So I'll just, last slide here, last two slides. There's some great resources out there, and one that's going on right now every Monday at 11 Central is the Yale Forestry Forum. So this is an online webinar series that talks about climate smart forestry. It's going on throughout the rest of the fall, and it's been absolutely fantastic. So you can find the recordings as well as sign up for future webinars there. Really, if you want to get a deep dive into this subject, it's a great place to go. These documents that I mentioned earlier, the Central Hardwoods Ecosystem Vulnerability Assessment and the Assessment of Climate Change in Illinois, and there's one in Indiana as well, are great documents. And then the Forest Service, the Fish and Wildlife Service has a new series called Ecological Forestry in the Context of Climate Change. And so it really highlights a lot of the current science and the current practices on the ground. And so it's another webinar series. I think there's one a month on it, but a great one to kind of look up. And then the last resource, which is absolutely fantastic, is the USDA's Midwest Climate Hub. So if you can go onto their website, they have topics in there. There's a lot of agricultural topics, a lot of urban, suburban topics, but there's a forest and woodlands topic there. And there's a lot of great articles and documents and resources for anybody that's just very, very interested into digging more into this, this topic. And so you can see here just a small number of some of the resources they have on that website. So if this is a subject that you're interested in, I would highly recommend spending some time on this Midwest Climate Hub's website and looking at all the resources and all the science that's out there, and it's included, in that website. And so with that, I really just wanted to highlight things and just kind of give a brief overview. I'll turn my video back on now. My email, you can see, is there in the bottom corner of this slide. And if you have questions or anything that you're more interested in this topic, feel free to email me. I'm happy to address them. And if I am unable to answer some of the questions, I certainly can help reach out to other experts and help you find the resources to answer those questions.
All right, Chris, thank you very much. I believe Hans is going to place a poll in the, there you go. If you wouldn't mind doing that poll for us. And I'll go ahead and go through the questions that we have. We have a few minutes for that. This first one is asking for your opinion. And the comment is, years ago, Nature Conservancy started the biggest threat to central hardwood forests, or stated that the biggest threat is overpopulation of white-tailed deer. Admittedly, a pet peeve of this person, deer continue to be a serious threat in forests in numerous ways. This is rarely discussed by most forest managers. Do you have an opinion on how this might change?
That's a great question. And I would say I certainly have an opinion. And it's interesting they say they don't hear a lot of foresters talk about it, because in the circles that I go in, I hear it a lot. And so white-tailed deer overpopulation is rampant in a lot of the central hardwoods, a lot of the Midwest. And it's very impactful to our forest, even outside of climate change. There's areas where we can't not grow an oak seedling without protecting it because there's so much deer on the landscape. There has been some really interesting research showing the combination of deer overpopulation and invasive species are kind of a synergistic effect where higher deer populations can lead to higher problems with invasive species. And so in terms of impacts on climate change, or kind of how that interplays with climate change and white-tailed deer, in my opinion, white-tailed deer overpopulation is another one of those stressors. And so climate change is a big stressor to our forest. And we know that when you have multiple stressors added onto a system is when you start getting big issues with tree loss and tree mortality, right? So maybe two-line chestnut borer, which is a common native pest, is not alone sufficient to really kill a tree. But when you add the stressor of heavy drought in this environment or really weird weather, then it may become a stressor that leads to, the decline of those trees, or herbicide, drift, or different things. So white-tailed deer are a additional stressor to an environment and to a system that I think would lower the resilience to climate change. And so I do think that managing deer populations in a more reasonable number, a lower number, is one way to create a healthier, more resilient system, which would be better able to adapt or resist some of these negative impacts of climate change.
Okay, I've got one on just to get your thoughts on, and admittedly, Illinois and Indiana both don't have a lot of areas where you can have enough difference in topography to have microclimates that would have significantly different types of trees growing and within a short distance of each other. But do you have your thoughts on whether maybe northern, in those areas where that may be taking place, where the northern slopes would be have a wetter situation and the southern slopes drier simply because of between the heat and the increased precipitation, and whether that would really change things very much?
Yeah, it's a good question. So we do see a lot of kind of local topographic variation in tree species. And for one example would be, even here in Southern Illinois, which we have quite a bit of topography, I'll say. But, if you're on the north side of a slope, you can expect to find northern red oak in there, different things. And if you get on the south side of the slope, you may find black oak, or blackjack oak. If the northern side of the slope, you may find a lot more sugar maple, and then the south side of the slope, you might find something different, right? So we do see variation based upon topography, whether it's slope position or aspect or other things. And that is largely another driver of our diversity. And so I would think that, with climate change, you're going to see changes to all of those. And you may see a little bit less changes in the northern slopes because they're a bit more shaded. I'm not sure about that. But I do think that, having the higher diversity systems with all these different topographic variations or slope position variations and the tree diversity that comes with that just does allow for a little more local adaptation with these species moving around a little bit and trying to find their best adapted spots in climate change. I don't think it's enough necessarily, but it certainly helps keep more species on the landscape in this situation. I think is the best thing we can try to do.
All right, thank you, Chris. And I think that takes care of the questions. Hans, did you want to mention anything about next week or next month's seminar? Or do you want me to do that?
Oh, I can mention that next month we're gonna have Keith Chirkauer joining us from Purdue. He is highly connected in groups nationally and going to share with us his thoughts on, I believe, particularly water resources and climate change. So stay tuned. That'll be a good one.
All right. Thank you all for attending. And again, if anybody has any questions, you got Chris's email. You can contact Hans or I for questions as well. So with that, we will let you go. Have a good rest of the day.
Thank you all.